Welcome to the lesson on polynomials in one variable. At the end of this lesson, you will be able to identify polynomials and non-polynomials, define a polynomial in one variable, state the general form of a polynomial in one variable, determine the degree of a polynomial in one variable, and determine the zero of a linear polynomial. Look at the expressions on the screen. Can you identify the polynomials in this set of expressions? A polynomial is an expression containing one or more terms where coefficients are not equal to 0 and exponents of variables are whole numbers. A polynomial can have one or more variables. Let's review again the expressions that we saw earlier. As you can see, the expressions are categorized as polynomials and non-polynomials. So, what's the main difference that you can see between expressions in the two categories? The terms of the polynomials have whole numbers as exponents, while the terms of non-polynomials have fractions or negative numbers as exponents. If you examine the list of polynomials further, you will see that some of them have a single variable x, while others have two variables, x as well as y. A polynomial that contains one variable is known as a polynomial in one variable. A polynomial in one variable can be represented as p of x, q of x, or f of x, and so on, where x is the variable. For example, p of x is equal to x squared plus 2x plus 1. The general form of a polynomial in one variable is p of x is equal to anx to the power of n plus an minus 1x to the power of n minus 1 plus and so on till a0, where an minus 1 and so on till a0 are real numbers. The exponents of terms are whole numbers. N, the highest exponent, n, is the degree of the polynomial where an is not equal to 0. You can name a polynomial on the basis of its degree. A polynomial of degree 1 is called a first degree or linear polynomial. The general form of such a polynomial is ax plus b, where a is not equal to 0. The maximum number of terms is 2. For example, x plus 1 is a linear polynomial. A polynomial of degree 2 is called a second degree or quadratic polynomial. Its general form is ax squared plus bx plus c, where a is not equal to 0. It has a maximum of 3 terms. For example, x squared plus 2x plus 1 is a quadratic polynomial. A polynomial of degree 3 is called a third degree or cubic polynomial and is represented as ax cubed plus bx squared plus cx plus d, where a is not equal to 0. Such a polynomial can have a maximum of 4 terms. For example, x cubed plus 3x squared plus 3x plus 1 is a cubic polynomial. Similarly, any polynomial of a degree greater than 3 is named on the basis of its degree, such as 4th degree polynomial, 5th degree polynomial, and so on. In a polynomial with one variable, the value of the variable where the value of the polynomial becomes 0 is the zero of a polynomial. In other words, the value of x for which the value of the polynomial equals 0 is the zero of the polynomial p of x. Let's take up a problem as an example. Find the values of a linear polynomial p of x is equal to 2x minus 4 at x is equal to 1, minus 1, and 2. Let's solve the polynomial for each of these values of x. First, substitute x with 1 in the polynomial. The value of the polynomial is minus 2. Similarly, the value of the polynomial for x is equal to minus 1 and x is equal to 2 is -6 and 0 respectively. In this example, the value of the polynomial is 0 when x is equal to 2. Therefore, 2 is the 0 of the polynomial p of x is equal to 2x minus 4. In general terms, if p of x is a polynomial and k is a real number, and if p of k is equal to 0, then k is called the 0 of the polynomial. You can determine the 0 of a polynomial through two methods, by trial and error and by equating polynomial to 0. Consider a linear polynomial p of x is equal to 2x plus 4. Let's first use the trial and error method to find the 0 of this polynomial. To begin with, let x is equal to 1. Substituting 1 in the polynomial, you get 6, which is not equal to 0. If x is equal to -1, then the value of the polynomial is 2, which is also not equal to 0. Try using another value, 2, as the value of x. The value of the polynomial is 8, which is again not equal to 0. In the fourth try, you use -2 as the value of x. You will find that the value of the polynomial is 0. Thus, using the trial and error method, you can determine that the 0 of the given polynomial is -2. As you can see, the trial and error method can often be long and tedious. An easier way to determine the 0 of a polynomial by using the other method, that is, equating the polynomial to 0. In this method, you can find the 0 of the polynomial p of x is equal to 2x plus 4 by taking x as the subject. Thus, p of x is equal to 2x plus 4. P of x is equal to 0. Thus, the value of the polynomial 2x plus 4 is equal to 0. On solving, you get x is equal to -2. This indicates that the value of p of x is equal to 0 if x is equal to -2. Therefore, -2 is the 0 of polynomial p of x. Thus, you can obtain 0 of a polynomial by equating it to 0.